Hello everyone, welcome to new lecture for this course. So today we see new concept or new thing which is about the GitHub or the Git version control basics. First thing, or in this chapter, we will be getting started with Git. We will begin explaining some background on version control tools, then move on to how to get Git running on your system and how to get it set up to start working with. So here at the end of this chapter, you should understand why Git is around, what's the importance of Git, why you should use it, and you should be all set up to do so. So as we said, we see why Git, or what is Git before, what is the difference between Git and GitHub, what are the different parts in Git, and what will be the difference between the version centralized version control and the distributed version control. Let's start with the first thing. So usually, or before Git, how it was working. For example, if you are working in a project or you are working in your lab, it will be long lab. So first thing, you will be using or creating a file named common app essay. Then after a few minutes, you did some changes. So you copy this file, you create new other file with another name, common app final, say final, but it's not really final. You need to add some other updates and you create another file, you copy the first one, you make your updates, etc. So how are you going to make sense of this? You have a lot of files with almost the same name, with a few changes between one file and another file. At the end, you will not know which file you are. Okay, honestly, you can know if you check the date, but it will be a mess. You are destroying your space in your laptop. You will get, or you will reserve a lot of space just for one file. So how can we optimize this? How can we create one file with keeping the historic for the updates that we did without getting all these files and all this space in the memory? So why we use version control? So one thing is, for example, we use the Dropbox or the OneDrive or whatever, and we put our file there. So here, the version history, here in the right, it will show you on the same file when you are changing or making some updates on the same file. Who did the updates, when, and what he did. So this is why here or another solution better than this one. So we create a shared file, a Dropbox or OneDrive or whatever. So we go File, View History, See Version History, and here we can see the history. Here, only one person is working on this file. So, and we can see from here the updates, when these updates are done and who is doing these updates, which is better solution with better solution. But this is for files. But if we are working with big project, we need a better solution. So here, the goals of version control system. So the version control records changes to a set of files over time. This will enable you to keep history of your work, summary, commit title, see which lines were code changed, checkpoint specific versions. Here it's known good state, recover specific state if you want to change some states or revert or whatever. The binary search here over revisions, so you can find the one that introduced a defect, because in every updates you did it in your files, this will be detected, and this will be added here as a new line. Okay, this person add these lines or remove these lines from this file. And if you want to make some into arbitrary changes without affecting prior or subsequent changes. So here we can also, or the version control system allow us to maintain multiple releases of your product. So it has a lot of advantages that we can benefit, and it will save us from many things: time, from ambiguity, from space, from many things. So who will use the version control? Everybody can use it. It can be used with large teams, 100 developers or more, with small teams between 2 and 10 developers. And yourself, actually, it's not for this course because the project was to be by team, but I just switch it to only one person. But even if you are working by yourself and your future self, because in the future we want you to use the Git and the version control to optimize your work. And here, multiple features on multiple computers. For example, if you are working in your laptop in your house, then you did some updates and you put your version, you are working in your version control. Then when you are working, you remember that you want to add some updates. So from the laptop of your work, you can access to the version control and add some changes. So here it's really flexible. It can be worked between teams, 2 or more, or even if you are working by yourself, it will be beneficial for you. Why? Because at any time from any computer, you can access to your work, to your version control, and check the history when you did these updates. So some examples, for example, we have the software development, the research, and it's really beneficial when we are doing some research, infrastructure and data, etc. Some documents here, like the version history in Google Docs. So how is the version control working when we are working by ourselves? We have the repository, for example, the database of edits and versions. And here we have our working copy. Here we are making the edits, we are making the changes, we are updating our files, our code, or whatever. So here, when we are working on your laptop, you commit to this repository, and then if you want to continue working on what you did after the last changes, you can just check the update, get the update from the repository, put it on your working copy and working on it. This will be really beneficial. So we have the old way of the centralized version control is when we have one repository and multiple working copy. Means we have multiple workstations, PC1, PC2, or laptop 1, laptop 2, laptop 3, etc. So here we have only one central repository, and all users commit their change to a central repository. Imagine that we are working in a group. The first student will be working here, the second student will be working here, and the third student will be working here. Every student will commit his work to this server repository. And then when to work on the latest version by all the students, we always download the latest version or get the latest version from this repository. This is the updated version, so we work on it. After finishing our changes, we commit the code or the project or whatever to the server repository. And here, everybody will get the latest update or updates. So each user here has a working copy. As soon as they commit, the repository gets updated. Here we have some example, for example, the SVN subversion, or the famous one, which is the CVS. So as we said, this is the old way. Now the new way, which is the distributed version control. So in this, or what is different here is compared to the previous one, that we have here some local repositories. So we have multiple copies of repository. Each user commits to a local private repository. Now it is commit, and it will get the update from this local repository. All committed changes remain local unless pushed to another repository, and no external changes are visible unless pulled from another repository. So as you can see here, we have some or another level added to the previous one. Earlier, or in the previous example, or in the previous version, we have the server repository and the working copy. We commit to the shared repository between all users, and we update everything from there. Now, from on this new version, the distributed version, we have the server repository, but we have some, or with every working copy area, we have local repository. So instead of, for example, whenever you are adding some lines to one file, instead of pushing this file to the repository and then push to the server repository, etc., we finish, for example, our part or our duty or whatever, what is asked for us to do in the working copy, then we commit it to the local repository. After we are done, we push everything to the server repository. Same here. If, for example, we are working in a project, someone is working with the some part 1, part 2, and part 3, and they are different. But at the end, we need to put all these 3 parts on the same project. So here, we need to push these 3 parts in the server repository. And of course, if you want to make some updates, we just need to pull the code or the project from the server repository to the local repository, and here we make or we did our updates in the working copy. For this or some examples, or this for this distributed version control is Git or HG, which is Mercury. But the famous one here, or the one that we will be focusing in, is the Git. So to summarize, we have 2 different version control modes. The first one is the centralized version control, and the second one is the distributed version control. The difference between these 2 is that we have another level of repository. We are adding the local repository. So every time we are working on the working copy, we commit our code to the local repository. If we are done, we can push our code to the server repository. Or every time we commit our code to the repository, whenever we add some changes, we commit our code to the local repository, and at the end, or when we have really something to push, we just push it to the server repository to be visible for all other users in this project, or shared by this server repository. So if the code is here in the server repository, all users that they are working on workstation 2 and workstation 3 can see what is inside this server repository. It means the server repository is shared between all the users working on this repository. However, when we are working, or when the first user is working on this repository, the 2 other users cannot access to this repository. Okay, so why Git? Git most commonly used software for tracking changes in any set of files. Usually, it is used for coordinating work among programmers or collaboratively developing source code during software development, which is really beneficial. So Git has many advantages over earlier systems such as CVS and Subversion, which, like we said earlier, it is this one. So for the Subversion, we have the checking over time. We have here the version 1, version 2, version 3, version 4, and version 5. And here for file A, this is what we changed in version 2. And after in version 4, we are just changing this. For file B, the first change was made in version 4 and the second is in version 5, etc. Now for Git, we always have track of everything, A, B, and C, and we add some updates. So here, A1, which is new compared to the previous version, then we have, so this is the A1 is the updates done for A. And here A1 is the same, so B is the same, B is the same, and here A2 is added or something added in this file, so here in version 4 we have A2. In version 5 we don't have anything really special, we still have A2. So as you can see here, we are tracking the files over the versions. So from where this Git come? So Git came out of Linux development community. The one who invented this is Linus Torvalds, and it was invented in 2005. The initial goals of the Git is the speed, because as you can see, you don't need to, for example, if you are working in group team, you don't need to wait, for example, for your friend to finish his work and give you the latest version to you to work on it, then send it to them, etc. You can always or all working at the same time on the same file, which this will accelerate work. Another goal is to support for nonlinear development. Here, thousands of parallel branches. We see what branch means. And it is fully distributed, is able to handle larger projects like Linux efficiency. And the global information here tracked with this acronym name. So what is GitHub? We know now, or we have an idea what is Git. Now, what is GitHub? GitHub was developed by Chris and Tom Preston and Werner and Scott using Ruby on Rails and started in February 2008. So Git started on 2005 and GitHub starting on 2008. This means, or from here, we can say that there is a difference between Git and GitHub. It is subsidiary of Microsoft, which acquired the company of 2018, etc. So github.com is a site for online storage of Git repositories. So in GitHub, GitHub is a site which will store our Git repositories. So you can get free space for open source project or you can pay for private projects. Now the question is, do I have to use GitHub in order to use Git? The answer here is no, because Git is not GitHub, so you can use Git completely locally for your own purposes, or you or someone else would set up a server to share files, or you could share a repo with users on the same file system. And in these three cases, you don't really need to download or to get or to use GitHub. You can only use Git. So Git is when you are working locally. GitHub when you are storing your Git repositories online on GitHub. So here to summarize the difference between the Git and the GitHub. Git is installed and maintained on your local system rather than the cloud. The cloud is when it is online. First development in 2005, and one thing that really sets Git apart is branching mode. We can have multiple branches. Git is a high-quality version control system. Now, the GitHub. The GitHub is designed as Git repository hosting service. Like we said, we can store our Git repository in the GitHub. You can share your code with others, giving them the power to make revisions or edits. So here you are working on a cloud and it is shared between teams or people. The GitHub is exclusively cloud-based. It's online. So GitHub is a cloud-based hosting service. However, the Git is installed and maintained on your local system. So this is the major difference between the Git and the GitHub. Now, we have some terms, famous terms on Git, which is branch, clone, fork. We will see what does this mean. So we have multiple, or consider we have multiple versions of your program. What if you have to support version 1.0.4 versus version 2? Or if you are, for example, you are working on Windows and your friend is working on Macintosh, and you want to both work, or you are both working on the same project. What if you want to add some feature to your project, if you want to fix a bug? So what will be the solution for this? Now the solution is again Git. So Git handles these problems by giving the branch, so you can start a parallel history of changes to the code in the repository. Clone, to make a copy of the repository to work on code changes. And fork means to make a copy the repository that will not necessarily be merged back with original, but it can be through a pull request. Now, let's start with the branch. So Git has a basic concept of branch. So branch is one history of changes to the code. You can have many branches, means you can have many changes to your code. And for each change, you have new branch. The lightweight, which is the branch, many branches. So the lightweight is every work item, feature, bug. So it has its own branch. For example, this is the main branch, and here we commit point represents one state of the program, and here we have a feature branch. So as you can see here, we can have many branches on the same project. This is for the feature branch. We can have another feature for bug, feature bug, etc. So there is one main development branch, which is here the main, and this is considered your latest working version of the code. You should always be able to ship working software from main. So whenever you check the main branch, you should have the latest version there. Now, as we said, you can have many branches. So the life goal of a branch is to be merged into main and deleted as quickly as possible. Why? Because we said that in the main branch, you will have the latest version. So whenever you have a new version, it should be merged with the main branch. Now, to develop a feature or bug fix, you need to create new branch and then later merge it with main. So why this is a good practice? So as you can see here, this is our feature branch, this is our main branch, and here we need to merge point branch software merged with main, done on GitHub. This is on cloud. And how we do this is git checkout b, and we give the branch name. So here we are merging this feature branch to the main branch. So to develop a feature or bug fix, we need to add a new branch. Why? Because we need to keep main always working and follows a parallel development. means we cannot add a feature or a bug fix and just add it to the main branch. Why? Because the main branch is the branch that contains or has the latest version and should be always working, because in any time or at any time everyone can access to it to get the work and finish working on it. So this version should be always working. It's okay to have many branches, and we need to fix these branches, then merge these branches to the main branch. So here, whenever, for example, we have a bug fix or something, it is really hot fix, or it's called a hot fix. Now, for example, we have another feature branch, which is here in green. So how to merge this? We need to add it to the main branch. So how the merge scenario is working? Scenario where merging is possible. So for now, we'll consider that everything is fine. We can merge without any problem. We have two types, from main and into main. So we can merge from the main and we can merge into the main. So the green one is our feature and the main, the blue one is the branch main. Now, if you want to merge here, integrating changes from main, so we are adding or we are getting the code from the main, adding it to the merge, the feature branch. So here, git merge branch name. So here we are merging in the branch name from the main. Now, first merge, it will resolve conflicts before pushing to main. Now, the second one is when we are integrating changes into the main. In the previous examples, we are merging into the feature branch. Now we are merging into the main branch. So here, the second merge will pull request to get your changes into the main. And here, we need to approve GitHub pull request. So as you can see here, from the green one, we are going to the main, the blue one, which is the main branch, to add or to merge the changes in the main branch. So the initial goal is to merge commit. So here, if we have, for example, a feature and we want to merge into the main, so this is how it is. Now we are merging the feature branch into the main branch. Now the squash and merge, which is here. So this is the main, this is the summary merger commit. So here we need to create a merge commit. The squash and merge wheel here shows that the 14, for example, commits from this branch will be combined into one commit in the base branch. Now, we said that we can merge, or these merges are when everything is fine, when it is possible. Means we don't have any problem, everything is working good, etc. Now, at some point, we can have problems or conflicts. How or what should be these conflicts? So, conflicts arise when two users change the same line of a file. When a conflict arises, the person doing the merge needs to resolve it by manual inspection. For example, we have hello world, then hello cat, and in another branch we have hello dog. So when we are merging, it will be conflict. Should we put hello cat or hello dog? So we both get the hello world file. We change it, but we change the same thing with different values. Someone changed it to hello cat and the other one changed it to hello dog. So this will be a conflict and it will cause a problem. And here, when the conflict arises, the person that is doing the merge means, for example, if I'm the one that I'm pushing the hello doc to be merged, I should take responsibility to resolve this by manual inspection. I should go and check when the merge conflict is, and I should figure out how to fix it. So another example. So here, line by line, merge reports pro. And here the inspection reveals they can be merged. Let's say we have our initial code is a function named def main. We have n receive 128 and print n. So in this small program, we are putting a value 128 in a variable named n, and we are displaying the value of n. Now, let's say we have two users here. The first one get this initial code, change it, and he changed this variable n to n people, and he still store the value 128, then it will print this variable. Now the second user gets the same initial code, the n receive 128, then print n, but he changed the value of that will be stored in n from 128 to 64. He didn't change the name of the variable, but he changed the value of the variable. However, the first user changed the name of the variable, but he didn't change the value of the variable. So as you can see here, between the user 1 and the user 2, we have two different changes. So when we try to merge these two files from user 1 and to user 2, a conflict will be rises. So here, when we are merging, we can have def main and people, which is the name of this one, receive 64, print and people. And here the merge inachievable by line-based merge. Okay, right now we could figure it out. We took the updates from the first user, we took the updates from the second user, we merged it together. It still works despite two changes. Right now, we are still good. The code is still working. Now, what if we have another code or another function called def multiplication, and we have two variables, a and b. So you know that to make a multiplication, we need two variables, variable 1 and variable 2, or variable a and variable b. Now, to calculate the multiplication, we are returning a multiplied by b. And in another function, def main, we are having a, which is another variable, receive 3, then printing or displaying the value of a. Now, this is our initial code. Again, two users get this code. The first user changed the name of the function from mult to multiply and keep the rest of code as it is, and the second user keep the name of the function as it is, the return as it is, but he changed the value of a. So when we are merging, what will be done? This will change the multiply, the thing that is changed here, and also it will take the updates from user 2. So here it is merged incorrectly because user 1 wants to keep the value of a as 3, and the user 2 keeps the value of a change the value of a to the call of this function mult, and change the value of a to 3, and the value of b is 5. So here it is merged incorrect. The function name changed, and this can merge cleanly, no textual merge conflicts, but it will result in code, the resulting code is incorrect. Because if we put this, or if we get this code, or if we push this code to the repository, the final repository, or it will be printing 3. However, if we are using this version of user 2, like it is merged here, it will print 15, which is 3 multiplied by 5, which is, of course, two different different results, which is incorrect. So we need to fix this. So how to avoid merge conflicts? We need to pull often to avoid getting behind the main branch, because if we just change this and pull our code, so this user, when he is or when he want to work on this project, he will get or he will get the name of the function is updated. Or for example, if this user just finish updating this line and pull his code, so this user, when he wants to get or when he check the main branch to get the latest version of code, he will get or he will find that this value of a is already changed. So he will figure it out if to change it again to a or keep it as it is. But we will not be facing this issue between the value of a here is 3 and the value of a here is the multiplication of 3 and 5. So the one solution to avoid this problem is to pull as much as we can. Whenever we are done, we pull our code or our project to the main branch. Because again, as a reminder, the main branch is the one containing the latest version. So whenever another person wants to work on the latest version, he needs to access to the main branch. Another way to avoid this problem is to push as often as practical. Don't destabilize the main build. Use continuous integration, automatic testing on each push, even for branches. And of course, avoid long-lived branches. Don't always try to finish, for example, small code here, then push it. Don't write too much in one function. If you can decompose your code or your project, just do it. It will be easier later to detect the conflict. So to commit also, we can avoid conflicts by committing often. So committing is when we did some changes and we want to put or we want to send our code to the main to the repository with a comment. So on the main branch, every comment should address one concept. Don't change too much and send it at once. If you, for example, changed the file 1, so make special comment for this updates on file 1. If you are changing on file 2, add another comment to this file 2. Avoid to change file 1, file 2, and file 3 and send them all or to commit all together in one commit. Try to specify or decompose your commits as much as you can. If you are done with file 1 or you did some updates on file 1, just make a comment for it. Done with updates on file 2, make another comment for it, etc. So every concept should be in one comment. Don't make a lot of changes and make a comment for all these changes. Every concept should be in one comment. This, as I said, will make easier the detection of conflicts later, because you will see after each commit the conflict arises. Another solution is when on feature branches, make a single concern commits and from branch back into main, squash, and merge. So it is easier to understand, review, merge, and revert if you want to change something in your code. So how to make a single concern comments? Do only one task at a time and then commit after each one. Like we said, if you have some updates on file 1, just finish it and commit. Don't wait until you finish the updates on file 2. Do a commit for file 1 before, then do another commit for file 2. Create a branch for each simultaneous task. You need to keep track of all your branches and merge. And it is easier to share work with teammates. Another thing is to multiple tasks in one working copy with multiple branches. So here, if you commit only a subset of file, for example, use the Git staging area with Git add. You will use it later. So you will, for example, if you have two files and you wanna put it in your working copy staging area, you can use the Git add. Now, as we said, do not commit all files. Use a.gitignore file template on GitHub. Don't commit binary files because it's useless. You will not need it later. Don't commit the log files and don't commit the temporary file. Only commit the file that it is needed to be used in your with your team project or needed to be used later. Don't commit this unuseful for in the GitHub. It is unuseful. Don't commit these files. Now, to plan ahead to avoid the merge conflicts. Also, you need to modularize your work or decompose your work. Divide work so that individuals or sub-teams own a model. Every person or every team has its own model. This will avoid the conflicts between teams or between persons. I have my own model, model 1, the other person have model 2, and the third person have model 3. Each one or each team will be working on its own model, and whenever we are done, we can push or we can commit our model. Other team members only need to understand its specification. For example, I am from Model 2 or I'm responsible of Model 2. I don't really need to understand what is going on in Model 1. I just need to understand its specification, generally what is going on there, and that's it. Because I'm responsible of Model 2, so if I'm not part of Model 1, so I don't really care what is going on in Model 1. Or until I need or there is strong link between model 1 and model 2, so then I need to understand how to get this task done. Also, we need to, or it requires a good documentation and testing. When you are committing your files or your code, you need to add some documentation or some comment. When you are testing, you need to add some comments or some documentation to make it easier later to the other person when they are reviewing or using your code, when they are getting it from the branch main. It will be easier for them to understand what you did and don't mess up your file or your code. You also need to communicate about changes that may conflict. So, for example, if you are working in teams, so you need to talk with your teammate why you did this. Why should I update this? Will it affect the overall work of the project or not, etc. Now, the Git workflow and usage. We have, or we saw earlier that some famous term is cloning. So when you clone a repository, you are creating a local copy on your computer that you can synchronize with the remote, ideal for contributing directly to a repository alongside other developers. So after you clone, you can use the git push to send the local changes to the remote repository. So when you are cloning, it is here you are working in the local repository. When you put git push, so you are sending all your local changes to this remote repository or server repository. So here we have the GitHub remote. Here we have the main branch, we have the hotfix, we have branch, feature 1, feature 2, branch, then we are cloning. So we are making a copy often on remote or local host. As you can see here, we are making a copy of this GitHub remote. Now another term, which is the forking. So on GitHub concept, not on Git concept, because forking is working on the GitHub and as we said, GitHub is only online. So forking means creates a new under-related repository, means GitHub project that is initially an exact copy, then changes to either repository do not affect the other, and it will allows you to involve the repository without impacting the original. So if the original repository is deleted, forked repository will still exist. So as it is, the fork that you are using to eat the pasta or whatever, it's the same thing. So you have the like what you said, the lines or whatever in the fork. So that's what we are creating. So if original repository is deleted, forked repository will still exist. As you can see here, we have the GitHub, and after making a fork, we are creating a full independent copy. It's possible here to update the original, but only with pull request. Means the original owner will need to approve or of course deny these pull requests. So these are the main concepts of Git and GitHub. By now, you should know what is GitHub, what is Git, what's the difference between these two, what is the difference between the local repository, the remote repository, how to make a merge, how to avoid conflict, what is a conflict, and how to avoid it. What does cloning mean? What does forking mean? Now, this is the general idea about GitHub. Now, in the second part, we are moving to install the Git version control utility. We need to copy two files. We are going to try to copy two files to the repository directory. We are going to display the repository status using the Git status. We are going to add files to the version control with the git add, display the difference between the revisions using the git difference, provide the minimum configuration info to git using git config. We will be using the git commit and git push. So to install the git version control utility, first thing we need to go, before this we need to go, okay, since I'm using my virtual machine, so I will open the github.com to install or to create a new GitHub account. If you already have a GitHub account, you can use it. Or if you don't have, you can go to your virtual machine, go to, for example, any web explorer, for example, Google Chrome, Opera, or whatever. Firefox, for my example, I will use Firefox. Click or put the link on the link github.com and create a new account. When you are creating a new account, you need to make the username and a password. Of course, you need to remember the password because you may need it later. So it will ask you when you are creating an account, it will ask you to put some code that it will get. So you need an account or an email for this account. You need to use, for example, your Yomish email or your Gmail or whatever, that later when you are creating an account on it, it will send you a code on your Gmail or email or whatever that you will use it to finish creating your account. So I created an account. This one, this is my username, Amal CHUM for Yumish. Then I will go to create. So this is my repository. Here, I just created a repository named test. I will go here to create new repository. For example, I will name it CSC137 and I will just create it. This link here, whenever you are creating a new repository, it will give you this link. This link, we will use it later, save it and don't miss it. Okay, now let's go to our code. So to install the Git on our machine, we need to use the sudo apt install git. So if we go here, go install git, it will ask you for your password and it is installing, downloading the Git. Okay, in the meantime, we can, or after we can make the sudo apt update, we can update the apt, then we will create an empty local repository, which is your sudo apt update. So here, if I check this one, I need to just remove this one. Okay. Now we are all set. We are ready to start working on Git. So we are going to create our new repository, mkdir git last. Then yes, so mkdir demo, so will be then cd git last and demo. Git class, yes. Oh yeah, because I created in the home directory. Okay, never mind. We will create another one here, access to it, and here we go. I will remove this one just to not confuse us. Then, so here we are creating our local repository. Then we will put git in it. So as you can see here, hint using master as the name of the initial branch. This is the default branch name. Hint is subject to change to configure, etc. So here we have some information. If you want to use git config local in a default branch, the name, etc. So here we are preparing for our local repository. Then we need to introduce ourselves to Git. We need to specify our username and the email that we are going to use it. So I will just be lazy and copy this one. And oh, So this is to say that this is my username, and to add the user email, we use git config global user email, and we give our email. I'm gonna change this. And here the user email. And here we go. So right now GitHub know that there is username is Amal CHUM, and with a linked user email, which is this one. Then, so we introduce ourselves to main. Before, we can have some, or these are some comments that we can use it when we are working on Git. To clone, and by now we know what does clone mean, means we are creating a Git repository so you can add to it. If you want to Git add files, means we will add the file contents to the staging area. If you want to commit, we will record a snapshot of the staging area. For Git status, we'll view the status of your file in the working directory and staging area, and the Git difference. We show only the difference of what is staged and what is modified, but in stage. And here, if you want to get some help, we can use the Git help and the command that we are using it, or we want to have some information about it. To pull or to fetch from a remote repository and try to merge into the current branch, we need to put git pull, and to push your new branches and data to a remote repository, we need to use the git push. So when we want to add a file to a Git repository, how it is going. So this is our file in which we'll be using, the file that we'll be using here is rows.txt. Then this is our staging area. We'll use the git.add. Now to move this file from the staging area to the repository, here we will use the git commit. Here again, it is a local repository, is not the remote repository, is not the server repository. So let's try an example. So here we'll create a rows file, copy the rows.txt to the demo folder. Then we will put the git checkout B and in the main. So we can just here access cd or create rows.txt. Okay, now we want to copy this file rows.txt into git class and demo. Now if we go here, we go to git class, we go to demo, we will find the rows.txt. Now we will switch to new branch main. Means here when we want to switch from a branch to another, we use git checkout dash b and we specify the name of the branch that we want to switch to it. Then we need to check the status of our git. So we will put git status. On branch main, no commits yet because we still didn't commit anything. Interact file. Here, this is the in file that if you want to use git add to include in what will be committed. And here what we have, Amal, have the documents, etc. So this is the status. Now, if we go to cd git class demo and we put git status, it will always show you what is the git status in your current repository or in your current folder. Git status on branch master, no commits yet, and here the interact file, which is the rows.txt. Nothing added to commit, but interact files present. So if you want to add this file, git add rows.txt. Now, if you want to check git status, oops, only git. See, now it is different. Earlier it was red, and here interact file now changes to be committed, is not interact anymore. So here new file rows.txt. Now if you want to commit, here git, and you will commit it with another with some message. So git, and we put commit -m my first file checked in. So here one file changed, 0 insertion, 0 deletion, and here create mode, and we give the name of the file. Now we put git log. So as you can see here, this is the ID or the number of our commit, and from head to the master. The one who did this is me, and this is the message in the comment. This is the message that we said that whenever you are committing something, you need to add a message to explain what you did, for example, to make it easier later for anyone that want to use your code to see what did you did after this commit. Now we will change the rows.txt file. Then we will change the status of this of git. Then we'll check the difference, and we will commit a m, and we will add a new message. So we go to roses. First line added, second line 2. Okay, and we save our file. Now we go here, we check the status, and it's mentioned that it is modified. Changes not stages for commit, but something is modified. Now, to see the difference, git difference. These are the difference. So 2 lines were added to this to this file. Now, if you want to commit, oh yeah, I should not be lazy and write everything. Okay, commit -a-m, here, new message. And here we go. So 1 file changed and 2 insertions. This is the difference. So now if you want to go to this file again, remove this one, and I will say that third line added instead of the second line. Second line removed. And we save. If we recheck again what we did here, so the status, the rows is modified. What is the difference? So this line is with minus is deleted, and what is added is these two lines. So here, as you can see, the content itself, this is from the beginning, it's there, nothing changed to it. Here, this line is removed and these two lines are added. Now, if you want to check, yeah, we check the difference. So we will commit it. Two insertions, we added two lines and one deletion. This is when we modify the file. Now we will add a new folder. We copy two files to that poem folder and we git add poem. So we go here, we create simple poem. Then we will copy. Let me go. Okay, so to show you, I will copy these two files, numbers and math that we used last time. So we need to copy. We need to specify what we are copying, numbers.txt, maths.txt into the git class demo and poem. Now, if we go here, we check git class, we check demo, we check poem. The two files are there. Okay, then git add poem. So we'll add this folder to git. Oops, I need to be in the local repository. So I need to go back git class demo. Okay, now the folder poem is added to git. Next, so what we are doing, we are adding multiple files, or file 1 and file 2, or numbers.txt and math.txt. We are adding them to the staging area. And so that's what we did here by making changing or copying these two files into the staging area. Git add rows.txt or numbers.txt or whatever, or poem, the folder poem that contains numbers and maths.txt. So right now we are putting these files into the staging area. Whenever we make a commit, we are storing these files in the repository. This is in the local. Now, when the general idea, this is the branch main, this is our staging area. This is when we put git add file1.txt. This is when we add the file2.txt to the staging area. Now, if we put a commit, so if you remember, we have here, when we make commit, we have some numbers. Commit A, so we have these numbers. As you can see here, when we are putting in the staging area, we have also these numbers. Then when we put a commit, the version through the version control, so here we have the head tint1, head tint2, etc. So we are adding a new branch here, or this will be the head will be added here. And if you want to get the latest version, git checkout, for example, if you want to check the head, git checkout head file1.txt. That's what we are going to do right now. So if you want to check the previous version, we'll do git this is the difference. Now, if you want to get checkout, updated one path from, okay, yeah, this is the one that I told you about. This is the number. So as you can see here is as updated from, and it gives you this number, the tracking number. So it means from where we got this file. Now, if we want to just check the head, you will see that we will get another number because they are not the same. So as you can see here, for each one we have different number. It will be updated, yes, one path from, and it will give you a tracking number from where you got this file to be updated. Now the push. So to make a push, now we are making our files in the Git repository, the local repository. Now we need to put the Git remote, or to push our code to the Git repository. We need two things. We need the local repository, which is your demo, for example, and we need the link to the repository. The link to the repository is the one that when you are creating your account, I told you that we will need this file. So here, so the local repository here is, wait, I will go back here and push everything in the Git class, or just the demo. Paste, wanna put local repository is the demo, and the link to the repository is the one found here. So I need to copy it and go here. Remove this and paste the copied link. It contains the GitHub, the username, and the name of your repository. Right now, it will ask you to, so it is added to a remote repository, or we are making the link between the local repository, which is demo, and the GitHub repository. Now, if you want to check git remote -v to see the versions of our repository. So we will see here the fetch and the push. Two things. Then to push our code, it will git push local repository. And from here, you need to put, for example, push demo. It will ask you for a password. So you need to enter your username. For example, for my case is Amal CHUM, and then the password that you're choosing when you are creating your account, your GitHub account. And after that, you will have your code pushed. So this is how to work on local, and then commit to commit your or to send your code to the local repository, then push it to send it to the Git repository. I didn't show you the local repository, the push, because it will ask you about the password, etc. Okay, the last thing is we need to ignore some things before sometimes. So configure Git to ignore specific files, explain why ignoring files can be useful, because you're, as we said earlier, when, for example, we have the binary files or the cache files or etc. So it will be unuseful for you, or it will be a waste of space of time for you to push this file. Then when you need to copy results folder with files here, as we said, when we are using the git ignore file, you can ignore these files. Thank you, and this was about the GitHub, the Git and the GitHub. Hope you enjoyed this lecture and hope you knew some new things, new informations about this really powerful tool, which is the Git and the GitHub. And I hope that we will be using GitHub in your future life. Have a good one, and thank you.